Last night we looked at the supermassive black hole at the centre of our galaxy. Tonight we're hunting aliens.
Plus we'll be revealing, and how incredible is this, how you at home helped us to discover a brand new planet.
I'm Brian Cox, he's Dara, and this is Stargazing Live.
Welcome back to the control room here in Jodrell Bank Observatory for the third and final night of this year's Stargazing Live, where we're going to be tackling perhaps the biggest question in all of science: are we alone in the universe?
Yes, we're living in a revolutionary period in the search for life beyond Earth. We're now able to find planets billions of miles outside our solar system. They're called exoplanets, and so far we've found over 700 of them. And just last month, scientists announced the discovery of Kepler-22b. Now, this is a planet which is quite close, about 10 light years away, and it's thought to be the closest one that we've come across beyond our solar system. This is an artist's impression of it, and you see that it's been painted as quite Earth-like with an atmosphere, and that's because it probably is quite Earth-like, may have an atmosphere, so maybe a strong candidate for life.
Now, one of the exciting things we can actually do here, because we've got this and we can use it, we can actually listen to Kepler-22b. Are we almost there with the coordinates?
All set up and ready to go.
So just press escape and Control-Alt-Delete. Control-Alt-Delete repeatedly.
Just return.
Just return. Are you sure
just return?
Just return. Are you sure
yes,
it's return?
It won't go.
It's a genuine note of peril for you. Here we go. Bingo, that's it. A monkey could do that. That will now turn to face directly to Kepler-22b. Later in the show, as it's turned around, we'll actually be able to listen to it. Plus, we'll be telling you all about the planet that you at home have found.
Now, last night we looked at light pollution, which is all the artificial light that obscures the stars in the night sky. In an attempt to show you how much light even the smallest places can create, we asked landmarks across the country to turn their lights out for us. And we decided to try and convince the entire town to switch everything off simultaneously live on air. Now, standing by for us in the town of Dulverton in Somerset is Mark. What's happening there, Mark?
Well, I've swapped the clear skies of Macclesfield for the rather more cloudy and wet skies of Dulverton, but the atmosphere is electric here. Now, it's quite a small town. I'm here on the high street of Dulverton. Now, it's a small town with about 1,600 inhabitants, 800 houses and about 50 shops, bars and restaurants, and we've been trying to spread the word to encourage people to think about their lighting.
Now, Mark, the weather doesn't look particularly good there. Does that mean that even if the lights go out, you're not suddenly going to see the Milky Way in all of its glory? You're not really going to see a tremendous show above your head, am I right?
I think we will not see an amazing show of stars over our head. The clouds are looking quite stunning at the moment. But of course, over the last few weeks, we've had teams working in Dulverton trying to spread the word. But in about 20 minutes' time, when the bells ring, we'll find out just how successful that word or that message has actually spread. Now, as this film shows, the message or the task was not an easy one.
Dulverton has 720 houses, 177 streetlights, 40 shops and cafes, 3 schools, 3 pubs and a sports ground. That's a lot of lights. If this is going to work, we'll need to get the whole town on board. First things first though, we had to meet with the mayor.
So what do you think is going to be the biggest challenge for us?
It's getting out the word to everybody that they should do what we want them to do, and that is make the big switch off, the biggest switch off that we can ever make it.
We knocked on hundreds of doors, dropped leaflets through letterboxes and spoke to as many residents as we could find.
I noticed that. You're going to be able to turn that off for us? Oh, even better. Hello. What lights do you normally have on?
Maybe the upstairs.
The upstairs light, yeah?
Most of the lights, yeah.
Thank you very much indeed for your support. No. And thank you too. I'm exhausted. I've been delivering leaflets all day, but the response, I think, has been pretty positive. I just hope they weren't telling me that just to get me off their doorsteps.
Dulverton is part of Exmoor National Park, which has some of the darkest skies in the UK. But even this relatively small town generates enough light to obliterate the stars with a fuzzy orange glow. Light pollution doesn't just reduce the visibility of stars. Light that shines where it isn't needed is a waste of energy and a waste of money. We've chosen Dulverton as our switch off challenge, but there are thousands of towns and cities all over the country that could benefit from a little less light. Only a few days to go.
This morning, one of the schools in Dulverton has allowed me to take the school assembly, and I'm a bit nervous because I've not done that since I was in school. But if I can get the kids on board, I can get the parents on board. So what we need you all to do is to go home tonight when you finish school and get all of your parents to turn off all the lights in your house. Are you going to help us? Yes, brilliant stuff.
But what we need now is some kind of signal to make sure that all the lights are switched off at exactly the same time. So I've arranged a meeting with the church bell ringers.
So will everyone in Dulverton be able to hear the signal?
If the wind's in the east,
Right.
they'll hear it, and if it's in the west, they won't.
Oh, so if the wind's blowing in the wrong direction, no one's going to hear it?
No.
Oh, crikey, so this might work and it might not work. Now, I've got to go see a man about some street lights.
Well, the majority of the lights will have to be visited individually.
We can't just push a big red button and it all turns off.
Could perhaps do that 20 years ago, but not now.
Crikey, that sounds like a big job. Do you think we can do it though?
Yes, yeah.
Well, we've visited hundreds of houses and businesses around Dulverton. We've spoken to the local mayor. The police are shutting the roads off for us. We've got posters up around the town. I really don't know if this is going to work, but if it does, it's going to be fantastic. Well, as you can see, the residents have turned out and there are hundreds to support this, including some hardy astronomers. So we've done everything we can do. So in 15 minutes, when the bells chime, we'll be entirely in the hands of the good people of Dulverton.
Thank you very much, Mark. Now, the weather isn't looking great, but we're going to persevere. It's just getting those lights off will be an achievement in itself. We'll be back to them very shortly. This is turning around in its own stately way. How far away? Because I think we had the wrong information there, didn't we?
Should have said Kepler 22b, about 600 light years away, so still relatively close, but we're going to have a listen anyway. I'm excited about that, actually.
Should be very good. Once again, you out of home have excelled yourselves with the photographs you've sent in. There's some absolute stunners there.
Yeah, here's just a few examples. This is a photograph of a star I know well, actually, because we talked about it on Wonders of the Universe. And there it is. Technology. There it is. It's a star called Eta. Oh, this is the Triangulum Galaxy, actually. This is M33, so that's not what I was going to talk about.
No, but that is nice, isn't it?
Well, isn't it? It's by Harry Page in Stanford, so the Triangulum Galaxy. This next one here, the Rising Sun, Richard Fleet from Wiltshire. And finally, and I think this is particularly nice, this is star trails over Jodrell Bank. So this was taken by Steve Warbis, who was one of the astronomers we had out in the dark, muddy field over there on Monday night.
Now, we do need you to keep them coming in. You'll find details of how to get them to us on the website. In fact, John Clayton said, Dara, where can we go for more information? If only there was a website, do you know of such a site? I have no idea what the website address is. It's not like I've said those words 9 million times. Where you'll also, by the way, on that website, I can't bear to read out, be able to join in with our live blog, Talk Stargazing, where Dr. Lucy Green is currently answering questions. That runs throughout this programme, and Stargazing Live Back to Earth, which follows immediately afterwards. She'll also be on during that. People have also been sending in their questions for Brian too. What questions do we have for Brian? Oh, no, we'll get to them later as the show goes along. Now, if you have a question, particularly something you want to know about planets or the search for life, you can get them to us by either emailing stargazing@bbc.co.uk or by using the hashtag #BBCStargazing on Twitter.
See, that was just a trick to get you to say it. You
God, they made me say
said it, bbc.co.uk. Now, although we're spending a lot of time looking for life on exoplanets, the best chance of finding life out there in the solar system comes not from the planets, but probably from the moons.
Now, we have probes, presumably, all across the solar system. On the majority of the planets in the solar system, we have probes at the moment. What are our best bets, though, for finding one?
Well, this is a picture of what probably most people think is the strongest candidate for life beyond Earth. It's Jupiter's moon Europa. Now, this was taken by the Galileo probe, which was in orbit around Jupiter. And it's not anymore. It was crashed into Jupiter. And one of the reasons NASA did that was to avoid Europa, because it's thought that, you know, it's just possible that we could have contaminated this if we'd crashed that probe.
So rather than landing our probe onto that, it was ditched, essentially.
Yeah, into Jupiter. Now, the reason we are very excited about Europa is that it's almost certainly got an ocean of liquid water beneath this icy surface. And there's probably more water in the oceans of Europa than there is water in all the oceans of Earth combined. So it's a fascinating world. The problem is the ice is probably around 100 kilometres thick. So it would take a big drill to get into that ocean. But it's one of the targets for exploration. The reason we know, by the way, is this is a close-up of the surface of Europa, again taken by Galileo. You see these cracks? Well, they are very reminiscent of the cracks in sea ice on Earth. And when you model that, it indeed seems that those cracks, which are constantly shifting, are shifting because this ice is floating on an ocean of liquid water. Now, there's another of Jupiter's moons, Ganymede, which we mentioned, I think, on Monday's programme, which is also a candidate for life because it also has, if not a complete ocean like Europa, then liquid water beneath the surface. And we think that it probably looks something like this. So this is a cross-section of Ganymede, and we think there's icy sludge there.
And the search for water is something that NASA take very, very seriously. They're going to Mars later in the year with the new Mars Curiosity rover. I mean, and follow the water is very much follow the water or follow those complex carbon molecules in organic chemistry. They're the things they're looking for. That's going to specifically land in places where they knew there was water. And the whole purpose of it is not to find life as such, but to find out whether the planet was or could be habitable.
Yeah, this is the Gale crater, which is one of the targets. And you find mineral deposits. If I just show you this picture, which is from the Opportunity rover, there's a mineral here called gypsum, which has been found in large quantities on the surface of Mars. That only forms on Earth in the presence of standing water. So it's probably the same on Mars. So we know there was water there once.
Okay, so that's going to land in August. Hopefully we'll be sending information back, and if we're back next year, we'll be able to show you some exciting stuff from Mars. Liz Bonham hasn't had the best of luck with the weather this week, but thankfully things are looking better tonight.
Hi guys, welcome back to the South African Astronomical Observatory, one of the greatest collections of telescopes in the Southern Hemisphere. We moved away from Salt now. We're at the 1 metre telescope, British built by Grub Parsons in Newcastle. Now normally this telescope looks at objects far beyond our solar system, but just take a look at this image it's taken for us of Saturn, 900 million miles away from us. Beautiful. Now, Neptune is our outermost planet in the solar system, another 2 billion miles outside of Saturn. But of course, that's not where our solar system ends. In fact, we've still got a lot to learn about this very mysterious region of space. The Karoo Desert might look a little bit more like an alien landscape than what we've got back in Britain. But this place is still unmistakably part of our home, planet Earth. Fertile soils, the warmth from our sun, a great diversity of living things. And it's all down to our unique position in the solar system. We're the third rock from the sun, not too hot, not too cold, just right for life to flourish. Of course, we're just one of a family of planets. It can be Venus. If my rucksack was the sun, we've got our rocky planets first. We've got Mercury, Venus, our very own planet Earth, and Mars. And then we've got the gas giants, Jupiter and Saturn. This would be Uranus. This is Neptune. And this is Pluto, which has been reclassified as a dwarf planet, so it's no longer a planet. But then what happens? What lies beyond our 8 planets? And where does our solar system actually end? Amanda Gulbis is an astronomer working here in South Africa. She specialises in the distant objects that inhabit the remotest regions of our solar system. Amanda, if this is Neptune, what's going on in the space between it and our nearest star, which would be over the horizon if it's 4 light years away or more?
Yeah.
Is it all empty space, or what's in there?
Oh, it's hardly empty space. We've discovered a lot of objects out there. Rocky, icy objects we call the Kuiper Belt. And we think that there are probably about 70,000 or more that are larger than a kilometre.
70,000 sounds like a lot of objects of that size swimming around in this area.
Right, except 70,000 are the biggest ones. And if you go all the way down to the smallest sizes, say a couple hundred meters in diameter, we think there are billions and billions.
How wide is it?
If you think about how far away Neptune is from the sun, the Kuiper Belt, the classical Kuiper Belt, is roughly that far away from Neptune.
Again, so it's quite wide. Does that mean that Pluto is now officially a Kuiper Belt object?
Well, Pluto it's in the Kuiper Belt. So it was the first of the Kuiper Belt objects to be discovered.
So if we've gone that distance from the Sun to Neptune again, and that's the Kuiper Belt, and here it is at the edge of the Kuiper Belt, here we are, What happens here? Is this the edge of our solar system?
Not yet. We still have objects that were discovered out here that have orbits that go beyond the classical Kuiper belt.
Okay.
We call those the scattered disk.
How many objects do we know exist in the scattered disk?
Oh, there's maybe hundreds, I think, right now. There are a few that are very well known, though. There's one called Eris. It's about 3 times as far away from the sun as Neptune is right now.
And what does it look like?
Well, we have an image. We have images from the Hubble Space Telescope, so I can show you one of those.
That's Eris. Okay. I mean, it's a bit blurry.
Right. Well, from the image, you basically are seeing reflected light. So there are severe limitations to doing that kind of imaging. And that's the farthest object that we've actually seen with the telescope.
So when you get to the edge of the scattered disk, surely that's the end of our solar system, no?
No, there's more.
So what's beyond that?
So beyond that is a structure that we have theorized called the Oort cloud. It's hundreds of thousands of icy objects that are in a big sphere all around the solar system. And it turns out that that's about half the distance to the next closest star, so it's about 2 light years away.
Is that the end of our solar system?
If you want to call it that, that's as far as we know. That's as far as we think that the sun's gravitational influence extends.
Okay.
And so that's where I would say it's pretty much the end of the solar system.
Now, Amanda, how do we know what this Oort cloud looks like if it's hypothetical?
Well, fortunately, we have observational evidence in the form of comets. So they come into the solar system from all different directions, and when we trace their orbits back, they originate from really far away. And that tells us that there must be a sphere of about 1 trillion objects that's out in the distant parts of the solar system.
Okay, and do all comets come from the Oort cloud then?
No. In fact, just a few weeks back, we had a comet that was visible from here called Comet Lovejoy. And we have a really great photo of it taken by one of our IT guys, not an astronomer. How cool is that?
Good stuff.
And that comet, we think, originated much closer in a place called the scattered disk.
Now, your area of expertise is the Kuiper belt and the scattered disk, and you mentioned that it's difficult to get a lot of information from just the images of these objects. So how do you study them further?
We have to be kind of creative. So we use this technique called a stellar occultation observation, and that's where we predict when one of these small Kuiper belt or scattered disk objects will pass in front of a distant star as viewed on the Earth. So it effectively casts a shadow. And the things that we can learn from that are things like its size and whether or not it has an atmosphere, properties of the atmosphere, how the atmosphere might be changing, and we can combine that with information we already know to learn things like the density. Even.
Okay, and is it easy to know where those shadows will be cast on our planet?
In fact, it's really hard, and we spend a lot of time exactly measuring the positions of the object in the star. And sometimes we get lucky and the shadow path comes over a place like Sutherland where we have a lot of telescopes, but sometimes we're not so lucky, and that's when it gets kind of exciting. So for example, last year, I ended up basically renting a pickup truck in Cape Town and putting a 12-inch portable telescope in the back and packing one of our special portable instruments that we built exactly for this purpose.
Okay.
And we ended up crossing the border up into Namibia and then renting a generator and setting all of this equipment up out in the middle of nowhere, basically, kind of looking over our shoulders the whole time for baboons and lions and whatever else might be out there.
Who says a scientist's life isn't exciting? And you were tracking a particular object that was quite interesting, wasn't it?
Yeah, this is one of the large Kuiper belt objects called Varuna, and in that case, it turned out to be kind of a strange result. We found that it suggests that the object is really elongated, and that's not at all what we would have expected.
Interesting stuff. Okay, come back to us later because I'm going to be finding out about Super Wasp, a very successful exoplanet hunter.
Thank you very much, Liz. Now, discussing as they were, the edge of the solar system, which is really where Voyager, or they're heading now at this stage, our furthest, most distant objects in space.
Voyager, it's one of the great stories in space exploration. It was I remember it vividly. It was launched in 1977, 2 of them actually, Voyager 1, Voyager 2. And they were launched to do what's called the Grand Tour of the solar system. So at that time, if you launched a spacecraft, you could visit Jupiter, Saturn, Uranus and Neptune in one mission. It happens very, very rarely. So off they went, ambitious spacecraft. But I remember talking to one of the designers, and he said they were designed to last about 2 years, 3 years, 4 years, because it's very expensive if you say this spacecraft will last for 20 years. You have to build it like a tank. I've got a picture of it there, actually. It's about the size of a bus or a car, actually. It's a tiny little thing. At the moment, Voyager 1, as you said, the most distant man-made object, it is 17 billion kilometres away. That's 114 times the distance from the Earth to the Sun. It's got a 16-watt transmitter on it. So think about that. It's almost like powered by a little battery, and it can be detected now. And what the Voyager 1 has done, and Voyager 2, is they're a place where the wind from the Sun meets the wind from interstellar space, and they're measuring that. Their instruments are still working, and they send the data back. And the coolest thing is that they do it on a tape. So there's actually a piece of tape. Now, most of our viewers who are under the age of about 20 won't know what a tape is. It's a piece of magnetic brown stuff that you use to record Top of the Pops on. And it records the data. And every so often, it gets its transmitter, points it at a radio telescope, smaller than the Lovell, actually, or similar to the Lovell, and sends the information back.
And NASA were saying today that actually they're turning off some of the parts of it even now to conserve energy, because I think they can keep it going until 2025.
Yeah, so there's some heaters been turned off. So it's now one of the coldest working things we've ever built, and it's sending the information back, and it should work until 2025. It's a brilliant example of what we can do when we put our minds to it.
Now, it's almost time to cross over to Dulverton for our live switch-off attempt. Before we do that, take a look at this.
Yeah, this is what Britain looks like from space on a clear night. So you see that you can see the major cities there. You can see London and Birmingham and Manchester and up to Glasgow and Edinburgh, Newcastle there on the east coast. So it's a mess, basically, if you're an astronomer.
60% of us now live in a severely light-polluted area, and it can play havoc with stargazing, and it's not that difficult to reduce. For example, several iconic buildings across the country have kindly been leading the way for us. This is Worcester Cathedral, and they switched off. Gone.
It's rather abrupt, that, isn't it? I hope it comes back. And here's Bristol's Clifton Suspension Bridge.
And even down in Cornwall at the Eden project, they've been dimming their lights for us in order to get a clear view of the sky.
Yeah. And then we've got the Spinnaker Tower down in Portsmouth. And there it goes.
And
so we can do
finally, this is BBC Media City in Salford, switching off its lights.
Yeah. They've gone beautiful. Now, we want to see just how big a difference the lights can make in even the smallest of towns. So to do this, it is time for Dulverton in Somerset to switch off. Over to Mark.
Well, this is it. After months of planning, the bells are going to ring very soon, and hopefully it's going to go very dark. So we need everyone in Dulverton to turn their lights off as soon as you hear the bells ringing. Now I'm going to invite my posse from Dulverton to help with the countdown. Now, I was going to say, are you ready for this, Dulverton? But I think you are. So we are now going to start the countdown. 5, 4, 3, 2, 1. Bam! And the bells will ring. This is the moment where the bells should start ringing. Instead, I want you all to shout ding dong, ding dong. No? Come on, guys, shout ding dong.
Now, Mark, we can hear the bells, Mark. We can hear the bells, and we can see the lights going out, except for the place beside you.
Oh, there it is.
There we go.
So far, then, the lights in this street have all gone out, and it's really eerie. Isn't it really quite bizarre, guys? Look at that.
You know, it's a shame, Mark. I suppose it is a shame that you can't see the sky. Doesn't seem to matter.
This is amazing. I can barely see the camera in front of me. It's got so dark. We can't see the sky, but what I would say is even though it's cloudy, the sky has just kind of leapt out above our heads. It looks amazing. We now have special night vision cameras because there's no light around. It looks incredible, but it's going to take a while for our eyes to adapt to the darkness. So come back to us in a few moments and we'll see how we're getting on.
You know, I think it's a wonderful moment, that. I mean, it's easy to just treat it as a bit of a stunt.
Yeah, stunt,
and I suppose it's cloudy, so you don't see the stars come out. But actually, there's a genuine point about losing contact with the night sky. I mean, if you think back to the time, well, I don't know how old you are, you can't think back to the time before electricity. Yeah. But then you know, the stars were visible, they were part of our lives, and it's the foundation of science, really. Astronomy is the oldest science. And so I think that motivation to understand that view, that if you live in a city all your life, you don't see it. I think it's a very strong one. So I think it's a very powerful thing to do.
It is. It's very, very striking. And something, you know, if we know we're doing it on a bad day, we know that the weather wasn't perfect for it, but if they can do that for us now, there's no reason they can't do it again and genuinely enjoy it at a better time of year. I
think so. Now, because it's the last show, I usually answer the questions, but because Dara has a degree in physics and cosmology from one of Ireland's finest educational institutions, we've decided we're going to switch over and we're going to ask the viewers questions to Dara. Go on. Change. So the first one, this is from Katie Stimson, and the question is, why don't planets twinkle? in the sky.
See,
what stars do.
I always presume that the reason stars shrink is because they're further away and there's more chance of fragments of dust or other things to pass away. But it's not. Because they're so far away, they're basically a point source of light. This is one single beam of light. So when it hits the atmosphere and gets bounced around by our atmosphere, it's more risky for it gets deflected. Yeah. Much better than planets, which have a number of points. They're just bigger. And so it's easy. Extended source, is that the term for it? Yeah, extended source. So it's easy for them when they come into our atmosphere to remain coherent.
That's exactly correct. And that's the only one we've got time for. Oh, but I'm sorry about that.
100% record.
If we find life in our solar system, it'll only be certainly at the microbial level. So if we want to find substantial life forms, then we're going to have to search for planets much further out into space. Now take a look at this image that was released 4 years ago by the Hubble Space Telescope. Now it's from a star called Fomalhaut, and I've got to click it there, so there we go.
Now, the star has been...
So it's a star called
remove the star from this image. So the bright centre is gone, so we can see what's happening around it.
Yeah, so what you're looking at here is a very young star. It's actually a very bright blue star. It's one of the brightest stars in the sky, but it's in the southern hemisphere, so we can't see it from here. But it's a very young star. It's about, 300 million years old or so. So you're looking at a primordial disk. So that is what our solar system may well have looked like well over 4 billion years ago. So that's interesting in itself. It's a very beautiful image. But the most interesting thing about this, and it's in this square here, and it's blown up, that there's a large object here, and it's actually a very large object. It is, in fact, a planet in the very early stages of its formation.
And is that, how rare is that to see? Has that just never been seen?
No planet had been photographed before. They're extremely faint, so we detect them by all the techniques we've been outlining in the programme. But this, from the Hubble Space Telescope, is an image of a planet. Now, you see, it's not moved very far. This is where it was in 2004, and it had moved there in 2006. Its year is 300,000 days long, so it's a very long way out from the star.
And is it gathering up and building up just like the process by which our planets were created as well? The dust is collecting. And
we think that planets begin very small, so only perhaps a kilometre across or smaller, and then over time in collisions they aggregate, and then the biggest ones begin to suck up all that dust, and eventually in that system you'll get a clean solar system like we have today.
Scientists have now discovered just over 700 exoplanets, but incredibly each and every one of these discoveries have been made in the last 20 years.
Yeah, now we've been observing nebulae, galaxies and stars of all different shapes and ages for decades, but we had to wait until 1992 to find our first exoplanet. And here's why. To understand why it's so hard to find planets orbiting distant stars, you have to get a sense of just how far those stars are from us here on Earth. Now, if I were to build a scale model of our galaxy, the Milky Way, starting here in the solar system with this as the sun, then let's say I put the Earth 1 centimetre away. So actually, if the Earth were that big, then the sun would be as big as this tea shop, but ignore that for a minute. Let's say this is the sun, and let's say I place the Earth 1 centimetre away. Now that's known as 1 astronomical unit. So if we go to the outer planet of the solar system, Neptune, that's about 30 astronomical units, so 30 times further away. Then onwards to the edge of the solar system, there's the ex-planet Pluto. And Pluto sits around 50 astronomical units away. So we've got about 50 centimetres representing the size of our solar system out to Pluto. Now, on here somewhere, on a mountain on the Earth in Hawaii, there's one of Earth's most powerful telescopes, the Keck telescope, and it took a picture of Pluto and its moon, Charon. And this is the best you can do with one of the most powerful telescopes we have. You can see that it's a disk, but it's a pretty featureless blob. At its furthest point from the Sun, Pluto is about 50 astronomical units away. But that's nothing when you're building a model of the Milky Way, because the nearest star to our Sun is 268,000 astronomical units away. It's a star called Proxima Centauri. And to mark its position in my scale model, I have to get much further out. If the Earth is 1 centimetre from the Sun back there in the tea shop, then Proxima Centauri would be here, 2.5 kilometres away. and that's just our nearest star. Now, the Keck telescope doesn't have any trouble seeing Proxima Centauri, of course, because although it's 4 light years away, it's 100 times the diameter of Pluto, and it's a star. It's a giant nuclear fusion reactor giving out light. But imagine trying to see a planet in orbit around Proxima Centauri. They're much smaller than the star. They don't give out light, of course, they only reflect it, and they get lost in the glare of the star. So trying to see a planet around Proxima Centauri would be equivalent to trying to see a grain of sand 100 miles away in the glare of a spotlight. Planets orbiting distant stars are so far away and so difficult to detect that we discovered one for the first time just 20 years ago. Far too distant to be seen by any telescope on Earth, it was found by scientists who weren't looking for planets at all. They were looking for pulsars. Pulsars are neutron stars, the remains of dead stars, the leftovers of supernova explosions, and they're incredibly small and dense. They can be the size of a city, but be more massive than the sun, and they can spin very fast on their axis. And when they do that, you get beams of intense radiation spinning around, sort of like a lighthouse beam, and that lighthouse beam can cross the face of the Earth. And so we see a series of bright, regular pulses, and that's what gives them their name. The timing of the pulses is so precise that they are as accurate and reliable as an atomic clock. But in 1992, scientists noticed something strange. One of the pulses missed a beat. It was as if the pulsar had wobbled. Now, our sun also wobbles as it spins on its axis, and that's because it's surrounded by planets. The gravitational pull of the sun keeps the planets in orbit, but planets are also massive objects, and so they exert a gravitational pull on the sun, and that causes it to wobble slightly. So those scientists back in 1992 realised that they were seeing the same thing happening to the pulsar. Those precise rhythmic beams were being knocked out of sync slightly by the gravitational pull of a planet. The discovery proved that there is a way to find planets that are too distant to be seen. They can be detected because they cause the stars they orbit around to wobble. And just 3 years after the first planet was discovered, another wobble was detected in a star in the constellation Pegasus. And this star wasn't dead like the pulsar. It was a star like our sun. It was the unmistakable sign of a planet. They named it 51 Peg B. The discovery of 51 Peg B was a real watershed moment because it's the first time that we found a planet orbiting a living star beyond our solar system. Now, today we found over 700 planets, which is fascinating in itself. But for me, the most interesting thing is that it takes us closer to a far more precious goal, which is to discover an Earth-like planet around a distant star, a planet that maybe could harbour life.
So I can see why a wobble would be obvious in a pulsar, which is sending out these huge jets of radiation. But a star like our sun doesn't do that. What is this wobble?
Well, the only thing you can do is look at the light. And stars, in fact, do wobble. We've got a graphic here which shows a star and a planet. And you see that the star, which is here, looks as though it's orbiting as well. And that's because it is. The star and the planet orbit around what's called their common centre of mass. So the star will move a little bit. Now think about the light that star's emitting. Now, if the star is coming towards us, then the wavelengths of that light become squashed, which means that the light moves to the blue bit, the shorter wavelength bit of the spectrum. But if the star is moving away from us, then the light is stretched and the light shifts towards the long wavelength red end of the spectrum. So that's called Doppler shift. So you can look at the spectrum of light from a star and you can see whether it's moving towards us and back and towards us and back. And by measuring that precisely, you can infer that there's a planet around it making that
So
star.
that wobble can only occur if a planet is making the star
Yeah,
wobble.
and really large planets, so there's a really substantial effect
So it's a
on the
big,
star.
big gas giant type planet. Radial velocity is used to find the bigger planets. But the best technique for finding smaller, more Earth-like planets is the transit method, which is what we've been using for our Planet Hunters experiment over the last 3 nights.
Yeah, the transit method looks for the dips in the light levels of distant stars as exoplanets orbit in front of them. So you can see this in the graphic here. The planet crosses the face of the star as seen from Earth, and the light level will drop until the planet leaves the face of the star.
About 35 of the confirmed exoplanet discoveries came from observations made in space by Kepler, the planet hunting telescope. But it is possible to search for transits from Earth as well. One of the best in the world is called SuperWASP, and it's based where Liz is in South Africa. Although not based there, but run from here, run remotely from Britain by scientists from Keele University. Believe me not, thank you very, very much. With simply the push of a button, somewhere Liz is standing next to it. If we just press this, I hope, then that should kick off.
Expert control.
There we go. How's that, Liz?
Good skills, Dara. Don't let all that power go to your head now. This is SuperWASP, super wide angle search for planets. And when Dara isn't interfering with it, it is run remotely from Keele University in Staffordshire. But one of their astronomers was actually in town a couple of days ago, giving SuperWASP a bit of an MOT. So I grabbed him for a chat to find out exactly how this gorgeous machine works.
So we have 8 cameras here, each of which has a really enormous field of view. The whole thing together, it images 1% of the sky.
It looks like a fairly simple setup. 8 digital cameras taking images.
It is.
How do you go about finding exoplanets this way?
So we monitor the same patch of sky 50 times a night, and we continue doing that for around 5 months.
Okay.
At that point, we've got a measure of the brightness of the stars over time, and we look for periodic dimmings that could be caused by a planet passing in front of the star. At that point, we use bigger telescopes in Chile using another technique to really confirm that it is a planet, and about 1 in 12 turn out to be so.
How many exoplanets has SuperWASP found?
So far, we found 75 and counting. The planets that we find, just because they're easiest for us to find, are typically what we call hot Jupiters. That's planets around the size of Jupiter, but much, much closer to their star than what Jupiter is.
Which one interests you the most?
One in particular that I'm fond of is WASP-17b. It's the first known planet to be in a retrograde orbit. That is, the star's spinning one way and the planet's orbiting in the opposite direction, which is completely counter to any planets known before and completely counter to any planet in the solar system. And it's discoveries such as these that are really helping us to refine our theories of planet formation and evolution.
With such a high rate of confirmed exoplanets, what's the likelihood of one of those planets actually sustaining life?
So currently we think that pretty much every star in the Milky Way does have planets, and the ones that are being found are increasingly like our planet Earth. So I think that the chances are very high, and in fact I think we'll find life on another planet within our lifetime.
And the reason why David isn't standing beside me right now for a bit more of a chat is that he's on his way to Chile right now to verify another bunch of exoplanets. So that means 75 confirmed exoplanets and counting. Watch this space.
Now, you saw right back at the start of the show that Dara controlled the Hubble telescope and pointed it in the direction of the planet Kepler 22b. It is now pointing straight at it, so it's right over there. Why have we done that? Well, look at this. Kepler 22b is one of our best candidates for complex life outside the solar system. Now, as I said at the start, it's 600 light years away, so it's a long way away. So I don't think we'll hear any signals from a civilization. But you never know. It's never been done before, which makes it, I'm quite excited about it.
And a number of our planets are in this region as well.
Yeah,
we obviously are.
Let me tell you what I mean by this habitable region. So there's a zone around any given star. Around the Sun, it's the zone, of course, in which the Earth sits. But actually also Venus and Mars sit in that zone. It's the zone where, roughly speaking, the temperature will be right for things like liquid water and rich oxygen atmospheres to exist on planets.
Now, it's not a given that life will occur. I mean, Venus and Mars, there's no real evidence of any major complex life on those.
No,
even though they're in the habitable zone.
Mars is too small. So it's in the habitable zone, but it lost its atmosphere and its internal heat early on. Venus, a runaway greenhouse effect, has made its surface actually the hottest place in the solar system, other than the surface of the sun. But Kepler-22b is in a similar zone around its star. So whilst you can't say for certain that it's a habitable planet, it could be like Venus, it could be like Mars, it could be like none of those three. But there's a chance that it's habitable, and that means there's a chance that that telescope is pointing at a civilization of aliens, and later in the show we're going to hear them. Who knows?
Joining us now to explain what this discovery could mean for us is exoplanet specialist Giovanni Tonetti. Now, this discovery, why is it so important?
Well, Kepler-22b is a very exciting planet because it's orbiting a star which is very similar to our Sun. Is at the exact distance to the star to potentially have liquid water in it. So that's why it's so interesting.
And what are we going to do? What's the next step? So how are we going to begin to characterise that planet and perhaps look for the signs of life?
Well, it's actually what we're doing already right now with planets which are slightly hotter and slightly bigger than Kepler-22b, is to use transit method to look at their atmosphere and so try to get basically the composition of the atmosphere. So what we are doing is look at some transit light curves and repeat that to different wavelengths.
So you have to wait again until the planet comes back around again
Exactly.
and then measure the light coming through the atmosphere to see what's in the atmosphere.
Exactly. Quite a challenge, but we can do that for bigger planets right now.
And what are we going to need to do that? I mean, is there a chance? As we said, Kepler-22b, a rather long way away. Is there a chance that we're going to be able to map that planet out in some detail?
Well, I'm afraid Kepler-22b is probably too far away to do this kind of measurement, but we can certainly do this kind of measurement of planets around the star, which are much closer to us. And certainly we'll do that with dedicated space mission in the future, like ECHO, for instance.
So, sorry, I just wonder, as the light goes through it, what are the telltale signs? What are you looking for?
Basically, we can extract a spectrum and look at the signature of some molecules. And in particular, if you're interested in habitability, if you're looking for a molecule that can tell us something about if this planet is inhabited or not. And so clearly, I would love to see liquid water, but or some water vapor. And in particular, having some signature or ozone or oxygen like on Earth, that would be a very, very interesting signal.
Yeah, because oxygen in Earth's atmosphere is only present because of the action of life in large quantities, isn't it? So if you saw that in one of these planets, then you'd be fairly certain that there was life.
Giovanna, thank you very, very much for coming. We have to go back over to Dulverton now, I'm afraid, because they've had about 20 minutes to get used to it.
In the dark.
Usually in astronomy, you take about 20 minutes for your eyes to really acclimatise to it. We're going to go pop back over right now to see how different the place feels. Mark, are you there?
Well, that was nothing more than amazing. To see the lights go out, and every single light that I could see in the main street has just gone out, and it went so incredibly dark. It's taken our eyes a little bit of time to adjust. It's just like being in the countryside, yet we're in the middle of a town. Now, joining me is Pete Tout, who's a local astronomer. Now, Pete, what does it mean to you, and what is it like to have all the lights out?
Well, this is very much like it was when I was younger. I could come out in the main street here and see the great ribbon of stars in the Milky Way. Now all the fainter stars have gone. It's a chance to get that back again.
And if, of course, if it was clear, then it would have been lovely,
It
I'm
would
sure.
have been absolutely glorious, wouldn't it?
It's great to see the way it's worked now. We're also joined by Jerry Whedon, who's the headmaster of the local school. Now, Jerry, the entire community has come together for this, haven't they?
Oh, they have. I mean, it really has captured the imagination of the community. You only have to have walked down the main street of the town, looked in the shop windows, and the effort that the shopkeepers have made, particularly the bakery and most magnificent cake. Hopefully, though, tonight's just the start of something and we get left with a legacy. Pete and myself have already been talking this evening about forming a local astronomical society and having a junior branch that's based at the schools.
That's incredible. Well, I think this has just shown tonight that regardless of the fact we can't see clear skies, everyone can take responsibility for lights. And if we all do that and just think about how we're using our lights, we can really make a difference. Now, if you want to learn a little bit more, then go to our website, which is bbc.co.uk/stargazing, and you can find a link to the Dark Skies Discovery Network, and you can find all sorts of information about light pollution. You can find out where your local dark spots are, and you can even recommend your own dark sites.
Hello there. Well, I have to say, I'm just the messenger here. I'm not the person who actually brings the weather, because one night this week we really needed those clear skies. At Dulverton, as you've seen, the cloud and the rain has moved in, and that's going to be the same story across many parts of central southern England and Wales overnight tonight. Best chance to get the telescope out. Northern England, eastern Scotland, Northern Ireland. Cloud amounts will vary from time to time, but there will be some lengthy clearer spells and even some clearer spells between the showers across parts of western Scotland. So for tonight, clearer spells in the north. Tomorrow we might actually reverse it a little bit. A scattering of showers expected, but these will be mainly to northern and western areas. Some of those will be wintry. Eastern Scotland, northeast England, get out early on before the cloud thickens up. But through much of England and Wales, away from the north and west, you've got a good few hours of clear skies before those cloud layers start to push in. Another cloudy day on Friday, but into the weekend, whilst we'll see plenty of showers, I think across eastern and southern parts, the air will be fairly clear at times. And with it, a cold air mass coming down from the north, the clarity of the air should increase as well. Whatever your plans, happy stargazing. Back to you.
You see, I thought that showed that there's a real spirit of stargazing there, even though it's cloudy in Dulverton. It said, just the act of making it dark, there's going to be astronomy societies formed, the school is going to get involved, there's going to be astronomers of the future coming out of that act, even though they couldn't see the sky.
And if you can do it for that, you can do it at any time during the year. Try it again. Just turn off the lights. Every light off helps the view of what's upstairs. We set the dish moving at the beginning of the show. We now have a unique chance to listen to the radio waves coming from an exoplanet, from Kepler 22b. What should we be listening out for?
Well, first we should listen to what the Lovell telescope usually hears. So this is the radio waves converted into sound. This is just space noise, if you like.
That sounds like fairly empty static.
So yeah, I mean, there's a lot of data in there. That's just radio astronomy going on. But now listen to this. Now, if you heard that, you would think that's regular, that's not natural. In fact, that is natural, that's the sound of a pulsar. But when it was first heard, the first pulsar was discovered, that was actually named LGM1, which means Little Green Men 1, because for a few days it was thought, how can something from nature be so regular? So if we hear that from Kepler 22b, which we probably won't, but it's not a pulsar, so if you hear a regular beat like that, then we would have to postpone the news.
For all the years of looking at, there's only been one incident where something was heard that we couldn't explain.
Yeah, it's a very famous signal. It's called the wow signal. Now, we don't have audio of that, but we have this picture of the wow signal. And you see, so that's a picture of the data from a radio telescope, and a very regular, very strange signal was heard, which to this day has not been explained. It's called the wow signal because you see the operator of the telescope there wrote wow next to it. Now, obviously, radio telescopes have gone back to that piece of sky since. They've listened very hard. Nothing has been heard since, but it still remains genuinely unexplained.
OK, Tim O'Brien, come back into us here now, because if we do hear something, you'd really want to be here.
Yeah, certainly. I've got my fingers crossed.
Yes,
so,
exactly. Yeah. Do we think we're going to hear anything at all?
Well, no, I mean, Tim, it's probably too far away, even if there was a very noisy civilization there, but you never know. If they put a beacon there, then maybe we'll hear something.
If they've got a strong enough transmitter, a big enough telescope, you never know.
Well, let's open up. Let's hear it. This is the sounds coming to us live now from Kepler 22b. Yeah, that's quiet enough now.
It's quiet, and of course that's what we expected. But Tim, very briefly, it sounds like a game, doesn't it? It seems like science fiction, but it isn't. There really is. There's the SETI project, which I know this telescope has been involved in, which is searching for signals from extraterrestrials.
It's a serious possibility. I mean, if you don't look, you're not going to find anything. So it's certainly worth having a look, or a listen, if you like, in this case, and analysing those signals very carefully, just in case.
And of course, the point of the search for exoplanets is, and rather than just chancing across it or looking randomly throughout the sky, now we can target, we can focus where we look for possible other civilizations.
Yeah.
Now, we may have been closer than ever to finding a planet with life, but the idea of attempting to communicate with distant alien civilizations is not a new one, which raises the question, what would it actually mean if we were to make first contact?
It's easy to find the idea of UFOs and extraterrestrial life a bit of a joke. But for centuries, scientists have taken the idea of alien contact very seriously. Early astronomy revealed our solar system contained other planets. And as soon as we thought there could be worlds like ours nearby, we couldn't wait to tell them that we were here, we were sentient, and we were dying to say hello.
If you look certainly at the 19th century, there were some quite prominent scientific figures who had really quite practical ideas for how you might try to communicate with alien life. So, for example, Carl Friedrich Gauss, who is a very famous mathematician and scientist, had an idea for cutting enormous geometric shapes into the Siberian forest that would be visible to anyone watching the Earth from Mars.
The great British astronomer, Sir William Herschel, discoverer of Uranus, was convinced life would be found nearby.
He felt quite strongly that the Sun might be a habitable place and it might be worth looking for life forms that we could communicate on the Sun.
As astronomy developed, it became clear that if aliens existed, they would be outside our solar system. And technology had to progress enormously before scientists were able to send out messages that could travel light years away to other worlds. In the 1970s, NASA launched the Pioneer and Voyager probes, spacecraft designed to explore the outer solar system. And in case they came across any aliens out there, on board they carried information about us. Pioneer contains a plaque, which has on it our location in the solar system, some basic scientific information, and most famously, a picture of two naked human beings, generally thought to be regarded as average Americans, in mellow greeting. You know the way average Americans are this buff and this hairless. By the time of the Voyager launch, more information could be encoded, including an entire disk of sounds of the Earth, more scientific information, and images of our history and culture. Whether of hunting, the moment of conception, and that guy. And images of licking, biting, and swallowing, as some sort of threat, presumably. To counteract that, we also included greetings recorded from people from all over the world in their own charming way.
Sayın Türkçe bilen arkadaşlarımız, sabah şeriflerinize hayırlı olsun.
However, these messages will be very difficult for any alien life form to find. Although the Voyager 1 probe is now the fastest and most distant human-made object in the universe, it's still comparatively nearby, inconspicuous and slow. Creatures from other worlds would literally have to bump into it in order to retrieve the message, and it won't even reach the nearest star system for another 40,000 years. But there was another way in which we could search for alien life: radio waves. In 1960, visionary astronomer Frank Drake made the first deliberate attempt to detect signals from other worlds. Scientists from around the world soon joined the search, which became known as SETI, the search for extraterrestrial intelligence.
What happened was that it dawned on radio astronomers in the 1950s that these big radio telescopes can really be limitless in size, and they're capable of enormous sensitivity. They communicate not just across terrestrial distances or even interplanetary distances, but truly interstellar distances.
But the fact that we can search for messages also throws up another question. What do we do if we find one? And what if by sending a message we attract the attention of great big extraterrestrial monsters who want to eat us? Even if their intentions are benign, we could be opening ourselves up to unexpected dangers. After all, our own history of encountering foreign cultures offers a cautionary tale.
Very often they started, like Captain Cook arriving in Hawaii, with utter best intentions and handshakes and smiles all the way around. But Captain Cook still didn't survive the encounter. And despite all the friendship and all the treaties, within 150 years, 90% of Hawaiians were dead. Even when things are all handshake and friendly, there can be terrible consequences.
Nonetheless, the SETI Post-Detection Task Group is standing by should an alien signal arrive. Professor Paul Davies could be amongst the first to receive a message from ET, and his response might not use words at all.
The things that we would truly share are the things that are literally universal throughout the universe, and that is mathematics and physics. The laws of physics are the same everywhere in the universe, and mathematics is, of course, the same by definition. On that, one could then build a broader dialogue, and so maybe after many thousands of messages back and forth, we could begin telling them about our politics and our sport.
And we can hope that their politics and sport doesn't include eating us. The truth is, whatever the price, receiving an alien message will confirm what some of us are desperate to know, that we aren't alone in the universe.
Now, 3 nights ago, we asked you to do something very special. We wanted you to help us find our own stargazing exoplanet. The response was incredible.
Here to tell us what we have found is the man in charge, Dr. Chris Linto. Chris, what happened? Have we found a planet?
We have, or we think we have, because we were looking for the dips in light in the star's brightness when planets get in front of the parent star, and we found one in particular that Lee Threplewaite and Chris Holmes told us there were these dips. We went back into the data and we found 5 of these dips, each of them 90 days apart.
Yeah.
So we think this is a planet that goes around this particular star once every 90 days.
So how many people responded?
We had over 100,000 people. We had well over 1 million classifications. I think it was 1,084,000 classifications.
Right, and these are just ordinary people, watchers of stargazing.
That's right. They went to the website, which you know so well by now. I'm tempted to ask you to repeat it.
Please
But
don't.
planethunters.org, logged on, and they did what people are still doing now.
Can we look at the data?
Yeah,
We've
yeah.
got
Let's
the
pull
data
this
here.
up. Let's pull this up.
And
Yeah, so there you
those
go.
2 people. So it was. Well, I want to name the planet. As well.
What were the 2 names again?
Okay, so this was the one that Lee Threplewaite saw. He saw that dip.
It was Threppleton.
Threppleton, well done.
Threppleton, yeah.
And then Chris Holmes on the right later on. That's 90 days later.
So just to be clear, what we're looking at here, we're looking at the light from the star.
Yeah,
and then
that's
there's
the
that
brightness.
characteristic dip.
That's right.
And it crosses the face of the
That's
star.
right. And if you look to 90 days after that, which we did, we dug into the computer.
Now, it should be noted, by the way, that there were others who also spotted it in these planets. They were after Threppleton and Holmes. But those names are running along the bottom of the screen now. You may have also identified this planet. And we feel there could be other ones as well once you go through all the data.
That's right, yeah. There's lots more we think we've got there. We've got more data we're putting in right now. So if anyone else wants their own planet named after them, they can go to the
so
site
carry
now.
on. Now, we've got an artist's impression of that planet, which is here.
The key thing is it's Neptune-sized, so it's probably gaseous, but it's a hot Neptune. It goes round its star just in 90 days, so it's about as close to its star as Mercury is to the Sun.
This is the planet that we are unofficially and therefore bindingly calling planet
Threppleton Holmes.
Threppleton Holmes.
Threppleton Holmes.
B. Yes, because the star will be A.
Okay,
Absolutely.
And where is it, by the way?
It's if you go outside now, stare about 10 degrees up in the northwest. That's roughly the right direction, between Deneb and Vega.
You never see it. I mean, like an amateur astronomer wouldn't find this star.
You need a pretty big telescope, but they found it online, and there are more out there. So
and it's a gas planet, so we wouldn't necessarily find life on the planet?
No, it's too hot. That's why you wouldn't find... It's inside what we call the Goldilocks zone, but it might have moons. So you can stand on one of the moons, look up, and gazing at the wonder that is Threppleton Holmes.
Do you know, I've got to say, thank you, Chris. This is incredible, I think, for me, that our audience have found a new planet around a distant star somewhere out there.
And then named
Galaxy.
after
That's brilliant.
2 guys we've never met.
Threppleton Holmes B.
What an amazing way to bring the programme to a close. Before we sign off, it's time to say goodbye to Liz, who's been in South Africa for us all week. We found a planet, Liz. Can you believe that?
That is such brilliant news. Isn't it astounding what we can achieve in this day and age? Now, look, I know we've had cloudy skies the last 3 nights, but it really has been a privilege to be here and to learn about these skies in the company of hugely inspirational astronomers. A big thank you to them. They've been wonderful with us. And armed with all these telescopes, they're helping us to take huge leaps in our understanding of the universe, especially when it comes to the hot topic of exoplanets. But their work is also revealing how much there is left to learn about our universe. Not just in deep space, but also within our very own solar system. It really is a very exciting time to be an astronomer, isn't it? So that's it from us, the Stargazing team in South Africa. We've had an amazing time here. Back to you at Joddle Bank. Goodbye.
And that is a glorious sky that she's seeing. Finally seeing a good sky over South Africa. Stay with us, by the way, for Back to Earth, which is coming up immediately after. We've many questions and issues to raise about the inhabitants of Threppleton homes.
I think they're warring factions. There's the Threppletonians and the Homians.
There probably are now. They didn't know until
All
this
kicked
moment.
off. My God. I mean, you God. Don't forget, by the way, there's more information on all this on the website where you can download a Star Guide, find details of all the Stargazing live events. Please come to some of those.
Can I say it? www.bbc.co.uk/stargazing. I've never said that.
Lovely stuff. Did it feel good?
I feel good.
Honestly, boring me. We'll see you in a minute for more of this. Will he be here?
We're just going to sit
in
there.
these chairs.
All right.
We'll see you in a second, all right? Don't go away.